Alright, hello. We're going to be discussing the extra credit number 2, and it states draw and name 4 constitutional isomers of C4H7Br. One should have a complicated substituent, exclude any alkenes. Alright, so let's begin by drawing the compound, which is C4H7Br. Alright, so before we do anything, we're going to have to determine the degrees of unsaturation, and to do that we're going to get the formula 2C plus 2 minus H minus X plus N all over 2. And that's the formula to determine degrees of unsaturation right there. And so what does this mean? This is a carbon. These are carbons. These are hydrogens. This is halogens, and that's nitrogen. You can divide that all over 2. So in order to get that, we're going to look at the compound over here and just plug in all the numbers you see. So carbon, we have 2 times 4 plus 2 minus the hydrogens, which we have 7. Halogens minus 1. Because there's only one, and since there's no nitrogens, we don't need to put anything there. All of that divided by 2, and that should give 2 times 4 is 8 plus 2, that's 10, minus 7 is 3, minus 1, that's 2, 2 over 1 is 2 over 1, 2 over 2 is 1. So what does this mean? Alright, this means 2 things. It means that there's one ring or one multiple bond. And since in class we were taught that multiple bonds are not a matter of us right now, we're only going to focus on the ring part. So this equals one ring in the whole compound. Alright, so let's start drawing. Now that we figured this out, we know that there's going to be one ring when we start drawing. Alright, so let's begin with the most easiest one. And this one is going to look like this. It's just a box. Each of these corners represent carbons. And you can branch out the bromine anywhere you want. So we're just going to do it right here. And remember that for every carbon wants to form 4 bonds. So there's going to be some hydrogens branching out over here and one over here. So that's going to be our first one. Let's do our next one. It's going to look like this. So we obviously know it's going to be a ring. There has to be a ring. So we're going to do it this way. It's going to be a triangle instead. But wait, there's only 1, 2, 3 carbons. We still need one more. Alright, this is an easy solve. We can just branch out one carbon like right here. And then another, and then we can branch out the bromine right here. And that's another form. So we have 1, 2, 3, 4 carbons. And to verify, you can count all the hydrogens if you want. All right, let's verify. So we have 1, 2 hydrogens, H, H, another hydrogen over here, H, 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 and then another hydrogen here. 1, 2, 3, 4, 5, 6, 7. All right, we have 7 hydrogens, so we're good. 1 bromine and 4 carbons, so that's another one. Let's do another version. This can look like this as well. We're gonna draw the triangle, and then we're going to make 2 little branches over here. And that's another version. We can put the bromine right here or the other way. Alright, so we can double check if you want. There's 1, 2, 3, 4 carbons, 1 bromine, and 1, 2, 3 hydrogens. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7 hydrogens. Alright. And since we only need 4, we're going to do 1 more. And this is going to look like this. Alright. We can do this, and then we're going to branch out like this. We're going to put the bromine at the end. Alright. So we have 1, 2, 3, 4 carbons. And then hydrogens, we have 1, 2, 3, 4, 5, 6, 7. And 1 bromine. So those are our 4 constitutional isomers. So now we're gonna name them. All right, let's begin with the first one over here. So to start naming them, we have to find the longest chain of carbons, always, or cycle. Since right here we have the longest cycle here, we're gonna circle this. And right off the bat, we're gonna know that it's gonna be cyclo something, we don't know what, but we can write our rules over here. So 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, and 8 is oct. I'm just gonna write these for now because I don't think we're gonna be going any further than that. So, because there's only 4 right here. So there's only 4 carbons. 1, 2, 3, 4. 4 carbons, and it's gonna be bute. So it's gonna be cyclobutane. This is gonna be, the name is gonna include cyclobutane somewhere. All right, now let's start naming them. And we know that the substituent has the lowest number. So this is gonna be 1, 2, 3, 4, or it could be the other way around. 1, 2, 3, 4. I don't think it would really matter because 1 is still gonna be in bromine regardless. And halogens always end in O. So with that in mind, it's gonna be 1 bromo. Why 1? Because 1 is branching, is the one that's on the branch right here. So that's why we have to put a 1 in front of the name bromo. And just put it together and it's 1 bromo cyclobutane. All right, and that's what we got for that one. All right, now for the next one. This one doesn't have 4, this one has 3 now. All right, so what's the longest chain that we have? And it's going to be this one again, the cycle. So it's gonna be, this one is not gonna be butane because there's only 3. It's going to be over here, we can look over here. It's gonna be the one that has the 3, so it's gonna be prop. All right, so it's gonna be cyclo prop propane. And why ane? Because it's alkene. So cyclopropane. All right, now we can begin by numbering our little drawing. So it's gonna be 1, 2, 3, or we can name it the other way, 1, 2, 3. All right, so we're gonna take this one, and it's going to look like this. We're gonna start naming this one right here. So it's gonna be 1 bromo. It's gonna be the same one as the top. And this one right here, this is a branch going to a carbon. 1 carbon, it's gonna be 1 methyl. It's gonna be 1 methyl. Oh, I'm sorry, it's not gonna be 1 methyl, it's gonna be 2 methyl. 2 methyl because it's 1, 2. We gotta remember our numbering system over here. 1 is in bromine, that's why it's a 1 here, and 2 methyl, because there's only 1 branch over here. And so it's gonna be 2 methyl. All right. So let's name this now. So it's gonna be 1 bromo, 2 methyl cyclopropane. And that's going to be it for that one. All right, let's move on to the next one. And this one it just keeps on getting trickier. So let's begin. We're gonna circle this. It's gonna be our cycle. So it's gonna be cyclopropane. cyclopropane again. And this one is gonna be 1-bromo again, because 1, 2, 3 name, we can number it either way. It's still gonna be 1 here, 1 there, and it's going to look like this: 1-bromo and 1-methyl, because 1 lands over here, it's the same one right here, so it's gonna be 1-methyl. All right, so what do we do now? Well, now we're gonna name them alphabetically. 1-bromo, since B comes before M. 1-methyl, cyclopropane. All right, and that's the name for that one. All right, now let's look at this last one over here. This one's probably a little trickier than the others, I'd say so. All right, so we're gonna circle the longest cycle. Cyclopropane is part of the name, and we can start numbering them. So substituting gets the smallest one. 1, 2, 3. All right, but now we have a branch over here, this little branch. So we don't circle this branch over here, we circle this one, and this is 1, 2, and since this is 1, 2, it's going to be 2-bromo methyl, because these two are connected. So this is going to be 2-bromo methyl. Oops. Methyl. And that's it for that naming. It's going to be 2-bromo methyl. Oops. I put bromo methyl cyclopropane. And that's going to be our 4 constitutional isomers.